Hi friends, welcome to my channel Code Destination. So today we are discussing the topic array. Basically, this is a special type of questions which is related to intervals. So in the array there are some special type of questions which deals with the intervals. So today in our challenge one code one day we will discuss that type of question because that type of question is very important in an interview. So for today we are taking this problem from LeetCode, problem number 56 named merge intervals. It is one of the famous problem and it is asked many companies. So today we will discuss about how we can think to solve the problem and how we can develop the logic. So let me share my screen. Yeah, so here already written some things to explain. So here in the question it is given that we are given the array here. Yeah, so we are given the array intervals. So basically every like intervals contain a start and end. So we can see here like in this interval every interval contains 2 point because one line contain a start and end points. So one interval represent one line, then second interval represent second line, and third interval represent third line. So in this way there are n number of lines. N is the size of array. So basically we have to overlap the intervals which is basically overlapping to each other. So like in this case 1 and 3 and 2 is 2 6. So 1 3 and 2 6 is overlapping, so the resulting it 1 1 1 to 6. So in the result we have to store 1 say 1 to 6. And in the second example 8 to 10 is not overlapping with 15 to 18. So second interval will be 8 to 10 and the third interval will be 15 to 18. So we have to we have to basically combine all the intervals which is overlapping and stored as a like whole result. So let me say here, yeah, suppose I took some example here, and initially what we can think, like we have given the array, so basically this all the points are distributed, so we can't like all the points are distributed. So when we try to think how we can like make sure that two intervals are overlapping, so for that basically we can think about the sorting because when we generally think the sorting behavior, when we want some like consistent behavior, like after the sorting what happened, like some of the smallest past will come left side and the greater part of the array will come the right side. So in this way like we can compare the uh, like neighbors and we can say that that interval are overlapping. But here the problem is that we have two intervals, so on which behalf, like on start point or on end point, on which behalf we can sort. So for that we can think like, so this is clear I guess why you have to sort the array, because with sorting we just compare the like consecutive intervals and we can justify that whether it is overlapping or not. If you are not going to sort, so like what happened basically, suppose there are some given intervals like that. Suppose I'm taking an example here. So suppose there are some given intervals. First interval is suppose here given, which is present suppose 1 to 3, and second interval given suppose um, 10 to 15, then third interval given 2 to 5. So like in this way it is distributed. So like we just by comparing these two we can't justify that what the actual range of the intervals which is overlapping, because maybe after that like it is not overlapping, but after that some interval is present which is overlapping. So basically we have to sort. So for sorting we can think in term of on like on the term of start point or on the term of end point we have to sort. So like in this case suppose we have, when we sort on the behalf of start point, so it will come like that 10 15. So in this way we can like by just comparing neighbors we can make sure that these two are overlapping, and we can just combine this, and after that whatever it should definitely not overlap. But why on the behalf of start or not on the behalf of end? For that we have to think much. So let me share my screen. Yeah. So here, suppose I sort on the behalf of endpoint. So what is happening? Suppose I sort this array like 3, 8. We have given this array and we sort this on the behalf of this endpoints. Uh, Suppose this and like all the and are sorted here. So what benefit we can get here? Like when we sort that, like on the behalf of endpoint, so what we can see, like if you consider this point and this point, so in this point we can compare this and the first end point and the second start point, and we can make sure that it is overlapping. But here the problem is that suppose this 2 point is overlap, so we can't like say that the actual intervals, like suppose these two are overlap, so like till here the interval are 3 to 9, right? Because these two like overlap and make the smallest point, and these two overlap then make the like largest point. So 3 to 9 overall, that will make the 3 to 9 here. But till this point we can't make sure that this is the interval. Why? Because maybe after that some point we get which overlap like till here to here, then our interval will sway, like interval will change. So in that case, let's suppose I store this interval, and after that I get some in between interval that is not overlap. So for that I suppose this interval, so this is not overlapping, so I store this interval like this two interval is overlapping, so I will store this start point and this. So like it will suppose add something, suppose this is 10, so 1 to 10, so this is the second interval. But for third interval, suppose it is coming here from 0 to suppose 13, so this will also store 0 to 13, but this is the wrong answer. Why? Because this 0 to 13 and 3 to 9 is also overlapping, so that will miss in our result, so that result will be not correct. So like in the third example also we can see, suppose this type of example is given. So by comparing these two, we can't make sure that what is the actual intervals, or what should be the interval in our result. Suppose in this case, suppose two this interval and this interval is not overlapping, so maybe I can say that this is our first interval 2 to 3. Okay, 2 to 3, and it is our second interval 4 to 5. This is our third interval, it's not overlapping. This is our fourth interval. So these four intervals will store in the answer, and maybe some interval after that we got which cover all the intervals. So in this way, like we will get at the last one interval which will cover all the intervals. So this all intervals combine into this. So in the answer we will get the wrong answer. So like just by sorting the last point, like we took this two example, by sorting the last like end point, suppose this is a start and end for every start and end. So if I sort the on the behalf of end point, so we can't get our like correct result. Okay, because suppose if you think like uh, we ignore whenever it not overlap, we ignore that. Suppose I ignore the answer in the answer, I ignore in the answer, and when I got any overlap I store. So in this way, for this case I can get the right answer. But this logic will not work if some interval overlap in between. Suppose this two overlap, and I can store in the 1 5, and after that suppose I got some answer like this 1 5 is not overlap to each other, so maybe I will ignore that, and it will not store. In which case it will fail. Like suppose I have this point 2 to 3, and here some point 3 to, or suppose 4 to 5, and this uh, suppose 4 to 6, and it is 5 to 9. So in this case this 2 3 is not overlapping, so I will ignore that. I will store only in the result 4 to 9, but it is wrong, right? Because in our answer it should be also present, it should be present. but when we think like that, in this case it is giving the correct answer, but in this case it is giving wrong answer. So on when we sort the endpoint, we can't get the correct answer. But yeah, the second option, when we sort on the behalf of start point, suppose I took this example, I sort on the behalf of start point. So like what benefit we can get, like suppose I sort on the behalf of start point, so there are one benefit we can get, like just comparing 2 point, we can make sure that if this 2 point is not overlapping, then further point will not overlap. Why? Let me explain you why I am saying this. First let me erase this. Yeah, suppose I erase this one. Yeah, okay. So I am saying, why I am saying that, suppose I am taking this example as 1 e1 s2 e2 s3 e3. So just by checking these 2 points is overlap or not, suppose this this is the sorted, so this is sorted on the behalf of start point, so definitely s1 like less than s2 less than s3. So I can see if the this point p1 like not overlap to p2, then we can say that p1 will not overlap the further point like p3 p4 p5, because like suppose when it will not overlap, in that case that start point will come somewhere from here, right? And we know like all the start point will be greater than that. So all the start point is like suppose s3 will start here or here, or like s4 will start here or here. So all the point will not overlap if this point is not overlapping to each other. So when we sort on the behalf of start point, so this benefit we can get, and due to this benefit, just by comparing these two point, we can make sure that the make sure and we can definitely sure that what will the total till this index, like this till this point, what should be the interval. So we can define that. Like suppose I am taking this two example, si ei and sj to ej. So suppose I want to um, I want to define the case when it should overlap. So like suppose I took this point, like suppose isi and ei, it is here, and for sj and ej there are three possibility. Either it can start here and end just before that, and maybe it can start here and it can end after the ej ei, sorry, and maybe it can start from like after ei and ej. So these two cases overlap and this case is not overlap. So in overlap case, what is happening, like if I consider like, and in all cases we sort on the behalf of start point, so like si will be always less than sj. But when it will be overlap, when sj point, this point will come before this point, right? So in all cases we can see like if sj start from here anywhere just before that, like in this range from where it will start, that will overlap. So we can make sure that if sj is less than ei, okay, we already know that as si is less than sj, and if sj is less than si, so we can definitely sure that it will overlap. But there should be second case, suppose ej, I am taking this second case, like ej will be less than ei and ej greater than ei. So in both case it may be overlap, may not be overlap. So with this condition we can't make sure that it overlap or not, but with this condition we can make sure that it should overlap, like it will definitely overlap. So the same concept we are going to use in our question. First like we define on the if we sort on the behalf of endpoint, so we can't get a right answer. So on the behalf of endpoint we can't sort, but on the behalf of start point when we sort that, so we can get some like benefits. Like suppose this I am taking two examples, suppose some point, this suppose I 1 to 3 and 5 to 10. So if this point is not overlapping to this point, so further point will not overlap, because further point will start just after that, because it is sorted on the behalf of starting point. So s3 max, like x3 should like s3 can start from here, here, here. So any from anywhere it can start, but that s3 will be greater than s2. So like if this 2 point is not overlapping, then it is sure that the like other point will not overlap. So due to this behavior, we will sort our interval on the behalf of start point. Okay, so let me write the code, because when we write the code, then with code we can understand the like problem and solution very efficient way. So what we are doing here, first we want to sort all the intervals on the behalf of start point. Okay, so I will sort it. So for array sort, I will use array sort, and what I have to sort, intervals I have to sort. And for defining sorting behavior, what I have to take, suppose I'm taking AB, so I'm using just arrow function for defining the behavior. So suppose I want to sort on the behalf of 0th, like start index, so I have to define like that. And if you want to sort on the like one index, so you can define like that, but we want on the behalf of start point. So yeah, I will sort it on the behalf of start point, and this is the arrow function like which define the sorting behavior, like what the behavior of sorting. So like here a and b is the array, because this is the like array of array, so it will pass one single array which is containing start and end point, and this is the second array, and will compare both array. So this is the sorting. So first I will define my start point. So I took 0, okay, 0 0, first start point, and I will define my end range intervals. So 0 1, so it is a start and end. Okay, then I will iterate in my intervals, all the intervals. So I intervals dot length to the length of total intervals. So for every intervals, if my like second intervals, if first this is the first interval, and in the second interval, for second intervals I have to check whether it is overlapping or not. So I can check like that. If intervals that start point is less than or equal to end point, like what is my first interval, if it is coming before that, here I explain now. If that that start point here, if that start point, yeah, this start point is coming anywhere in between, so it will definitely overlap. So that what is the condition, if my sj, like second point, like second for the second interval, what is the start point sj, if it will come like it will come less than or equal to ei, which is the end point of first interval, then it will definitely overlap. So here I make the condition, it will overlap. And in the overlap case, what I have to take, okay, yeah, one thing we have to notice, when it overlap, so how we can define the range, like in this case if it is overlap, so what the range, let total interval, it will be the minimum of si and sj. Here I can see minimum of si and sj, and maximum of ei and ej. Okay, because in every case, like if it will come here, here, or here, in all cases it will take the maximum range, because we have to define the whole interval after overlapping. So I will take here maximum range, and in here what the minimum range. Okay, so same thing I will do here for defining the end point. What I have to do, I will check max, what is the max, I will check. So previous endpoint and what is coming new endpoint, I will take the maximum, and for start I will check the minimum, math.min. So here start and intervals I and 0. So in this way I can define the range. And in the else condition, if it doesn't overlap, it means that interval should come in our answer. Okay, so for taking the answer, what I can define, we don't know the size of the, like this, what the number of size of intervals. So I will use array list for that, because we need some dynamic size. But in that I will use the array, because that two size, every interval come only start and end. So in the result I will store this. Okay, array list I will take. Yeah, so I will store that. First I will store my result, that interval. So I will store like that. My start and end will store. Okay, and when it doesn't overlap, so again new start and end point will start. So like my start point will be intervals. Okay, so it should start point should be here, and yeah, endpoint should be here. So like here I explained already. So like if all the point is like here, this 3 point is overlapping, so i will I will get the resultant this line from here to here. But suppose some point start from here to here, so this is not overlapping, so this result will store in our result. And after that, whatever point will start, for that we again like define my start and point. And suppose any overlap, then it will take the like min and max, then it will store again the new interval in our result. So in this way it will combine all the intervals which is overlapping. Okay, in this way we can define. And at the last interval I have to store. Okay, basically what we have to return here. Okay, we have to return here basically not array list of integers. So for that I have to define my result. But before that we have to take care one things, like suppose at the last it will come in the else condition and it will store that interval. But after that it define there are some interval, it contain start and end, so that we are missing. So we have to store that as well, like at the last start and end point. So I have to store that as well. So star end. So in this way we will store all the start and end, like start and end point. Basically we will store all the intervals like that. And at the last we will define our range uh, result which I have to return. So for that now we are knowing that how many result we can get. So whatever the result size, that much interval I will get, and every interval has two, like start and end. So here I can get. So I will again loop in the intervals. Results dot length. So in this way I will return what type of data our like return type wants. So in the result I and 0, what I have to store, result dot get I. Okay, it will return the array, then 0 data here. And in the result of I and the one index, because it's the endpoint, so from result I will get first ith data, then there one index is endpoint. So I will store in the result like this. And at the last I will return my result, which is the array of array. So let me run it first. Yeah, it is giving some error. What error it is giving? Okay, it is result, not results. And yeah, let me run it again. Yeah, so it accepted, both the cases pass. Let me submit it. Yeah, so it accepted here. So it is taking 8 millisecond and beats 89.63 of user Java. So I explain here logic the same logic I write the code. Like first I define why I have to sort on the behalf of start point, so I just sort it on the behalf of start point. Like here I define the area sort, and here I have to define the behavior. So basically you can learn in Java how we can use, like suppose on the behalf of some parameter I want to sort any array, so how we can sort. So basically I just write the smallest syntax so that you can understood easily. And just I define the start end point, and I found whatever the intervals is overlapping, and if it is overlapping, just I define the range uh, of the overall interval. And if at any point if doesn't overlap, it means that is our result, first result. I store that start end point, then I define the start and new start end point. So after that same thing will happen, like it will search for that start and end if there are any overlapping. So in this way, for every start and end point, it will combine all the intervals together, and it will give our overall start and point, and we can store in our result. And at the last we just did for this return type, because return type is not an array of int, like array list of integer, like array list of array, but we need to array of array. That's why we just convert into the array of array and return. So the same logic follow. I think you ungot the logic, and I think you can connect the logic with the code. So let me cover the also what the time complexity. So here, if my interval size is n, so it is just array sort, so n log n, because any sorting method like this Java sorting method is generally taking n log n. And here we are iterating n times, so it is total n iterations, so big O of n it will take. And other is constant operation, so total n operation, big O of n, and it is big O of n log n. And if I combine both, so this is n log n operation and it is n operation, so n log n, it is basically n plus n log n operation. So total it is big O of n plus n log n is time complexity, which is internally we can see that because n is like n log n is greater than n, so it is n log n time overall time complexity. And if I'm talking about space complexity, we are using this array extra result here and storing in that result. So it is total if the size of array is like suppose I am ignoring this 2 size because it will be less, so suppose it is n length, so it will take big O of n, or we can see into 2, because we have like that 2, because it is containing area of array, so it is big O of 2n. Basically space complexity, internally we can see that big O of n space complexity. So it is a big O of n log n time complexity, and big O of n space complexity solution. So I hope you understood the intuition behind this, how we build logic and how we code that. So if you like my explanation and this video, please like this video and subscribe my channel, so that in future if I upload any video, you can get and you can learn. So thank you for watching my video.